Hello geometry students. Here's your lesson for section 7.3, Triangle Similarity, AA, SSS, and SAS. Missy McCarthy, Okemos High School math instructor. In this lesson, we'll learn to prove that certain triangles are similar by AA, which is short for angle similarity, SSS, which is short for side similarity, and SAS, which is short for side similarity. And we'll also use the triangle similarity to solve problems. Just in case you don't remember what a postulate is, I have the definition here for you. So there are a couple different versions of the definition, but the one that we use for postulate is to assume. So postulate is to assume that something is true for mathematics without proof. We don't need anything to be proven, any logic used. We're just going to assume that it's true. So our very first postulate is the angle similarity postulate, which says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So how does this contrast to what we've been doing before? Well, before, for our definition of similarity, we had to say that all three angles in one triangle or one figure were congruent to all the angles in another figure, and then all of the sides in the first figure had to be proportional. The corresponding sides were proportional between the two figures. Now in this particular lesson, we're just talking about triangles. In the first lesson, it was any polygon. In this lesson, just triangles. And the two triangles will be similar, and the only thing that we need to say that they're similar is that two angles in one triangle are congruent to two angles in another triangle. We don't need to know anything about the sides. So if we look at these two triangles here, we want to be able to show or explain why they are similar. So we have triangle BAC and triangle EDC, and we want to explain why they are similar. Well, the first thing we can say is that angle A is congruent to angle D because we have the right angle congruence theorem that says that all right angles are congruent. And then we know that these two angles are congruent. Angle DCE is congruent to angle ACB because vertical angles are congruent. So that's by the vertical angles theorem. Oops, vertical angles theorem. So because we have two congruent pairs of angles by the angle similarity postulate, we can finally say that triangle BAC is similar to triangle EDC. Notice I was very deliberate about the order in which I placed the order in which I placed the letters to make sure that B corresponds with E, A, and D, and C corresponds with C. Now, the next thing we're going to look at is a similarity theorem, the side similarity theorem. And this one says exactly what you think it might say, except instead of that word congruence that we used to use with the side congruence theorem, because this is a similarity theorem, instead of saying that the sides have to be congruent, we're saying that if the sides are proportional. So if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So we would have to say AB is to DE just as AC is to DF, and just as BC is to EF. If all three of those ratios are equal, then the two triangles are similar, without knowing anything at all about the angles. So let's take a look at these. It says verify here that the triangles are similar. So we're going to take a look at triangle PQR and triangle STU. So the very first thing I would do is look at the ratio of PR to SU, and that ratio is 2 to 3. then I would look at the ratio of QR, and that would, if we go PR, QR, SUTU, and that would be equal to 3 over 4.5. And then we would have to do TS. Oops, I shouldn't have that on top. I should have the other one on top. QP to ST, and that would also be 3 to 4.5. So if I double this one, I actually get 6 over 9, which is the same as 2/3. This one also 6 over 9, which is the same as 2/3. So I showed that all of the sides are actually proportional. They're all equal to each other. They're all equal to 2/3. Therefore, the triangles are similar. Here, we have to pay attention to our 70-degree angle. So H corresponds with D. And we can look at then DE to see if it is proportional with HJ. And we can also look at, let's say, DE, HJ, the hypotenuse, which would be DF, and HK. So are those two equal? Well, DE is 2, and then HJ is 1, and then DF is 5.8, and HK is 2.9, which is half of, or 2 over 1. This would actually reduce to 2 over 1. We don't know the third pair of sides. Now, the directions say to verify that the triangles are similar, but we don't know the third pair of sides, and we don't know that it's a right triangle. This one, to be honest, is going to use something that comes up in the next slide. Okay, so we'll hold on to this one. Look at this. Okay, so instead of having 3 congruent sides, or 3 pairs of sides that are proportional, we have 2 pairs of sides are proportional and 2 corresponding angles that are congruent. So I am thinking that this example is misplaced, and that this is going to be an example of side angle side congruence. Side angle side congruence. So let's look and see if there is a side angle side, not congruence, I misspoke, similarity. And there is. Side angle side similarity says that if 2 sides of one triangle are proportional to 2 sides of the other triangle, so that's definitely the case that we had, and their included angles are congruent, the 70-degree angles were the included angles, then the triangles are similar. So we've got side angle side, side angle side, the angles are congruent, and the sides are proportional. So that does make the 2 triangles similar. So if we were to go back to this example, we could say triangle, oops, let's write on there. Triangle DEF is similar to triangle HJK by side angle side similarity. Okay, so let's look at this example and see if we can show that these two, actually we're going to be proving that these two are similar. So if what we're given here is that oops, not given, not very polished today, statements and reasons. Okay, so our first statement is that 3 UT is equal to 5 RT. That's given. And we're looking at UT, this one here, and RT, which is this one right here. Now, if we were to use division, my second step is going to be that UT is to RT just as 5 is to 3. And that's nothing more than the division property. Now I'm going to use the other statement that they have here. 3VT is equal to 5ST, which is also given. And then I'm thinking we can write, that means that VT is to ST just as 5 is to 3. And in order to get there, again, I've used the division property to rearrange that cross product back into a proportion. So I have two sets of corresponding sides that are proportional. I either need another set of corresponding sides or I need an angle to use the proportionality or the similarity theorems. So one thing I see here is that this angle is congruent to this angle by vertical angles. So I'm going to keep this color. 5, we can say angle STR is congruent to angle, let's see, we would do VTU, and the rationale or the justification for that would be the vertical angles theorem. So we have two pairs of proportional corresponding sides, and then we have a pair of congruent angles right in the middle. So we can say triangle UVT, and this is our step 6, is similar to triangle RST, and our justification will be by side angle side similarity. Okay, same things as before. Rewatch any parts of the video for full understanding. And that should not say of ratios and similar figures. I don't know what was going on with me. This should say triangle similarity, angle, angle, side, 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 and side, angle, side. If you're watching, feel free to type questions, and you have something to look forward to in the future. CT will be presenting your lesson, but not for section 7.3. That's the lesson you just received. CT, which is one of the teams in second hour, will be presenting your lesson for section 7.6. So you'll have something to look forward to. I see you in class.